Hello, everybody. I'm so sorry not to be with you guys today. It would be very good for Miss McFarland, but I have a meeting this afternoon at school that I have to be at. So go ahead and open your notes for section 5.3, polynomial functions. Hopefully you've already gone over your homework. I want you to start out by doing this warm-up activity. You can work on it, with somebody near you. And we'll press pause on the video when you work on this problem, and then you can check your answer. Y'all can discuss it together. Okay, so you've done the problem. Here is your answer. You can check that with each other. Hopefully you just realized you needed to divide, right? If you know that the volume of a box is length times width times height, this is your volume. So they gave you the height. So you just need to, sorry, that's supposed to be a times. You just need to divide by the height to figure out your other two factors. The challenge was you ended up getting a quadratic after you divide, and then you factored it. So hopefully that was fun. Y'all can talk about that together if you need to pause it. I know Maggie got it the other night, so y'all can explain that together. What we're going to look at today are polynomial functions. So we've already talked about polynomials. This first list really, it's just kind of for your reference. We've talked a lot about the degree and the terms of a polynomial. And the biggest things you need to remember is a polynomial specifically cannot have variables in the denominator. Those are things, they're just not polynomials. So, and here you can see some that we've looked at before. We've obviously seen constants where the degree is 0 because we know that that would be like x to the 0 and x to the 0 is 1. Anything linear is degree 1. Quadratics are degree 2. And so you can keep going. All right, so what we're going to learn in this section is that the degree is actually very telling about the type of graph it's going to have. And it also is important to look at the leading coefficient because it tells you a little bit about the graph as well. You remember when we had quadratics, if we had y equals negative 2x squared, you knew that this is the leading coefficient and it opened down. That was important. Same thing for a line. We knew the difference between y equals 2x, y equals negative 2x. One has a positive slope, which means it went like that, and the other had a negative slope, which means it went like that. So the degree and the leading coefficient are important. So here, you're going to take a second and tell, first of all, if it is a polynomial, you can tell what the degree is and what the leading coefficient is. And if not, you just say it's not a polynomial and tell why. So press pause for a moment and on the video and take a moment to do those. All right, we're back. So this one is not a polynomial. Hopefully you recognized that that was the problem. All right, here, this is a polynomial, degree 6, and the leading coefficient was 5. Here you have a degree 4 and the leading, oh no, look at that, they tricked me. We can't decide the degree without looking at every term. We can't assume it's in order. And so here the degree is 6 and the leading coefficient is -1. You could rewrite in descending order of degree. That's typically how we write something in standard form. Descending order by degree. The coefficient obviously just goes along with the number. All right, so if it is a function, we're talking about polynomial functions, then we can find the value of the function. This is not new, all right? You remember if we have f of x here equals x squared plus 2x minus 3, we could find f of -1. You should be able to do that. So take just a moment. If you need to, pause the video. All right, so hopefully you squared -1. And you did 2 times -1 minus 3, which is 1 minus 2 minus 3, which is -4. So we found that f of -1 equals -4. So that means the value of the function, if we graphed it, if you go over -1, you would have to go down 4 to be on the graph. That's what that says right there. We don't know much else yet. Unless you thought about it, you could figure out more. But we do know that. Now, this is where this book wants to get just really fun and make our life hard. Okay, so we know how to find the value of the function, but now we want to find it putting variables in, and not just any variables, but very complicated sorts of things. So I'm going to erase this stuff that we just did. All right, now bear with me here. If we want to find f of 3c minus 4 minus 5 f of c. Okay, so first, find the first thing they ask you to find, f of 3c minus 4. Then you can go back and find f of 5c. Sorry for all the noise. Or just f of c. All right, so we are going to plug 3c minus 4 everywhere we have an x. So we have 3c minus 4 squared plus 2 times 3c minus 4 minus 4. You're going to crunch that out. And then in the second part, you're going to plug in c everywhere there's an x. So you do c squared plus 2c minus 3. So when we do this first part, 3c minus 4 quantity squared, and add all of that, I'm going to just go down to my answer. Hopefully you have done all of that. We get 9c squared minus 18c plus 4. And then it told us to do minus 5 times that stuff that we got up there, c squared plus 2c minus 3. All right, so I'm going to get rid of that line now, and I'm going to combine, do some distributing and then combine like terms. Minus 5c squared minus 10c plus 15. Now combine like terms. 4c squared minus 28c plus 19. So honestly, this is nothing that you haven't done before. There aren't any skills involved that you haven't done before. You're substituting into a function to evaluate the function, and you're also then having to combine that with what you know about squaring binomials and combining like terms. So it's very layered, but not a lot of new. So that's the good thing. All right, so I'm going to give you a moment. You can pause the video. I want you to try example 3, and you can look at the answers as you get them. So go ahead and press pause. All right, the next thing we're going to look at, and this will be kind of brief. I promise we're going to talk about this again tomorrow. But the degree, we already talked about that the degree of the function tells you some really important things about the graph of the function. And if you look at this chart, it kind of sums it up. You already knew that anything linear, degree 1, makes a line. And we spent a whole chapter studying quadratics, where anything with a degree 2 made a parabola, and it either opens up or down. And now you can see that we also have very similar patterns with the higher degrees. Everything that is cubic has that kind of snake-like feature. And the dips, the high and the low, they vary based on what's going on with the function. Same thing for quartic and quintic. Okay, so I want you to notice some patterns. Look at the even functions, the degree 2 and the degree 4. Look how both ends are either up or both ends are down. That is always true. If it has even degree, it's either both up, both down. When it's odd degree, one is up and one is down. You can even see that from our lines. One end is up and one end is down. So that's a pattern I just love how God puts all these patterns into nature and then we discover them. All right. So the degree and the leading coefficient determine a lot about the graph. Okay. We knew that with our parabola, it's even degree, so both ends are up or down. And we know they're both up when it was positive and both down when it was negative. So I'm going to show you this notation. And then I'm going to kind of leave you alone to let you read through the notes and look. But we use this notation to say if we look at what happens here, as x gets bigger, which means as x goes toward infinity, that's what that means. As x increases, what is happening to y on the graph? On here, as x increases, as x goes to infinity, y, or f of x, also goes to infinity, right? And what happens on this side? As x gets smaller and smaller, which we say as x approaches negative infinity, the y's, they get bigger. F of x, or y, still approaches infinity. So this is some fancy notation when we talk about end behavior. Okay, I'm okay with you using words. You can say as x increases, f of x increases. Or here, as x increases, this is as x gets bigger, what happens to our y's? Oh, they're dipping down farther and farther. Sorry, I wrote an x. Here, y, or f of x, approaches negative infinity. It's getting smaller and smaller. I'm okay with you writing it in words like I have here and here, but you do need to understand. If I write those, you need to know what I'm saying. So you can decide if you're going to use the notation or words. That's completely up to you. But I want you to spend some time investigating these notes, reading, and looking at the homework. We're going to do, again, 2 days on this, so do not panic, okay? Here's some for the notes. You can go ahead and stop the video, work through the notes. When y'all are ready, if you want to check what you wrote for those 2 on the notes, you can do that. Okay, there you have your answers. I hope you can read them. Good luck. We'll talk about this tomorrow. I will not be here for tutorial because I'm in my meeting, but you can email me. But really, truly, don't panic. This is a 2-day lesson anyway. I just want you to see what you can figure out. Love you guys. I hope you have a great afternoon. Goodbye.